All right, ladies and gentlemen, as we get going, we're going to basically go through it and graph like we just did. This is essentially a review day of everything that we did, 9-1 and 9-2. There's just one more additional thing we're going to do. So as we take a look, warm up for today, let's review on how to graph these two functions. So the first one is what we call standard form. I've got, again, y equals ax squared plus bx plus c. And if it's in this form, there's a little formula you guys need to know. What's that little formula?
The quadratic.
Quadratic formula? Good guess. Good guess.
The binomial.
Nope, not binomial. Good guess. I call it the AOS formula. You guys remember what that is? It's been a long time. We had spring break. Axis of symmetry. Does anybody remember? X equals x equals negative b over 2a. You remember that one? Okay, so again, that's going to be that axis symmetry line that's going to go right through the center and cut that vertex, right? Cut that quadratic, that parabola in half, and you're going to find the vertex by plugging that thing in. Okay, so those are the first two questions on your quiz. So as we take a look, what's b? So I got a -2, and then 2a. What's a? The number in front of x squared. What is that number? Just 1. Gail's giving me the finger back there. It was the index finger, though. That's okay. All right, 2 times 1 is 2, and we simplify, get x equals -1. So that's our axis of symmetry, so we graph that guy. Here's -1. Any questions on how I got -1, y'all? We okay? Any questions how we got -1? Now, our vertex is somewhere on that line. So if you remember way back, the last thing you did, took that little quiz, we said, well, that vertex is somewhere on -1 something. And this is where if you want to, you can use your calculator, right? If you're really bad at plugging in numbers. I usually just do some of this in my head. So the first thing I'll do is I'll plug in -1. What's -1 squared? What's -1 times -1? 1. What's 2 times -1? -2, and then +3. And I got 2. So I got -1, 2. Is everybody okay with that? Just a reminder, anytime you square a number, it's always positive. So I got -1, 2. 1, 2, right there. There's my vertex. Now, it doesn't have an a value. A value is 1, so it's going to follow the basic pattern of a parabola, where it's over 1, up 1, and then over 2, and what's 2 squared? Up 4. It's going to follow that pattern. Over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. It's symmetric. Dun, 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 dun. It's symmetric. So I get a nice, pretty parabola. So that's review from chapter 9.1. Okay. And then in 9.2, we gave you something that's called vertex form. Looks like this. So I've got vertex form, y equals a, x minus h quantity squared, and then plus or minus a k value. So a reminder, your h and k moves it left or right. I always say opposite of what you see. So in this case, if you see an x minus 3, it moves it to the... Gail's pointing to the right. Very good, Gail. And the k value moves it up or down. It does what you think. Positive goes up and negative goes down. So this thing's going down. It's yelling timber. You better move. You better dance. Hashtag Kesha. So your vertex has now been moved over to the right 3. So your vertex is normally at 0, 0. It counts over 1, 2, 3, and then we go down 1, 2, and 3. So that vertex is now 3, -3. Any questions on why I got 3, -3? So far, so good? Now, normally this graph goes like it normally does, right? Unless there's an A value. Do we have an A value? A, do I have an A? Yes, Ivan's shaking his head. A, what's A? What's this guy? A is -1. So if it's negative, what do we know?
Negative.
Smiley face or frowny face if you're negative. Frowny people, oh man, they are negative people, aren't they?
And Packer fans.
And Packer fans, yes.
And White Sox fans. Negative.
Oh.
Last
Oh.
I checked, my dad's not a negative person.
Oh, he's not. Is he a Sox fan? Yeah. All right, so A. Normally we go over and up 1. Now we're going over and down 1. Over and down 1. Now again, 3 points is the minimum vertex and 1 on either side. You can do a couple more if you want. Okay. In this case, I'm going to go over 2, and normally I go up because it's positive, but now I'm going down. 2 squared is 4. 1, 2, 3, 4. Over 2, and then down because it's negative. 1, 2, 3, and 4. And just for fun, what's that axis symmetry? What's that AOS? X equals what? What's this line right here? X equals?
Are you going to the answer?
Yeah, Ivan's given 3. There's that axis symmetry. X equals 3. Example 1, we ask you to get the axis symmetry first, plug that in to get the vertex. Example 2, we got the vertex. Now you should be able to find the axis symmetry and graph the rest of it. Just be careful with A values. A is going to stretch it or flip it if it's negative. Okay, so that's great review from 9192. You guys have any questions on that? So if you weren't here on Friday before spring break, that's what we did. We took a quiz on this stuff. Okay. All right, new stuff. Here we go. Here we go. It says, in order to solve a quadratic equation by graphing, we can use the following step-by-step process. Again, if it's given a quadratic equation that's equal to 0, it's going to look like this, then we just graph it. So if it looks like this, we graph it, and we know how to do that. We find that axis of symmetry and graph it. Number 3 says, look for the places where the function crosses the x-axis. The solutions of the equation are the blank of the related function. We call these the roots. So we're going to look at the x-axis. The solution of a quadratic equations are called blank or blank. X-intercepts or the zeros of the function. How many solutions are possible? So you guys might graph something, and what we're looking is we're trying to find out where this function is equal to 0. We're trying to find these intersections right there where it crosses that x-axis. Those are called x-intercepts, also known as zeros or also known as roots. Okay, so there are 2 solutions here. Sometimes your parabola might just kiss that x-axis and only have one x-intercept, which means there's only one solution. And sometimes you might have a smiley face or frowny face that might look like this, or might look like this. And then do either one of those have x-intercepts? Nowhere, right? Doesn't touch the x-axis anywhere, so we would have no solution, at least no real solution. So that's going to be the scenarios. Where are these x-intercepts at? And what we're going to do is we're going to work on our graphing from chapter 9.1 and 9.2 and find those intersections. Okay, now again, we're not going to do every single one of these, but kind of go through some of these and see what we get. Okay, so here we go. Again, this is great practice. All right, so it says solve the following equation. So now you see that it's x squared minus 9 equals 0. We always want our stuff equal to 0. If our stuff's not equal to 0, we got to get our stuff equal to 0. In this case, we have that. So now we're ready to graph this thing. Okay. Does this look like vertex form or standard form? This looks like standard form. This looks like that y equals ax squared plus bx plus c form. So in this case, we need our axis of symmetry. We need this guy, x equals negative b over 2a. All right, b. So a reminder. So I have this here for you. B is the number in front of x. I've got an x squared, excuse me, I got an x squared and a negative 9, but do you see an x term? Do you see an x term? What is it if you don't see it? 0. Warren's giving me the 0 back there. And then a. A is the number in front of x squared. If there's not a number in front, we all know that is a 1, right? So that's 2 times 1. Well, this is 0 over 2, and what's 0 divided by anything for axis of symmetry? 0 divided by anything is 0. So I've got an axis of symmetry right here at 0. So far, so good? All right. Vertex is 0 comma something. All right. Plug in 0. 0 squared minus 9. What's 0 squared minus 9? So again, if I'm graphing this equation so you guys can see what I'm doing in terms of algebra, if I plug in that 0 for x, what's 0 squared minus 9, y'all? Damien? What's 0 squared minus 9? Just negative 9. There we go. So we get a vertex of negative 9. So negative 9 is all the way down. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then we start graphing. There's an a value of 1, so it's going to follow the normal pattern. Over 1, up 1. Over 1, up 1. Over 2. What's 2 squared? 4. So I go over 2, up 4. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Now, yeah, I could graph this, but I want to know where this thing touches or intersects the x-axis. So I'm not quite there yet. I'm going to keep going. If I go over 3, that's up how many? What's 3 squared? What's 3 times 3? That's 9. So I'm going to go over 3, up 9. That hits right there. There it is. There's my answers. This is what we're looking for. Those guys right there. Where do they intersect? What's this guy? 1, 2, negative 3, 1, 2, positive 3. So my answers are plus or minus 3. Okay, so that's my solutions for this. Now I can always check my work now. If I plug this in, is 3 squared? What's 3 squared? 9. 9 minus 9 is 0. Works out. If I plug in negative 3 squared, negative 3 times negative 3 is 9. 9 minus 9 is 0. Works out perfect. Okay. This is another way to solve a quadratic equation, is to graph. Okay? All right, questions? All right, let's take a look at the next one, number 4. And we're trying to find out where this graph touches or crosses the x-axis. As I look, I've got x squared plus 4x equals negative 4. Is that what I want? Can I graph this yet? Shake your head no. What do I need to do first? Get your stuff equal to 0. I'm going to go ahead and add that 4 over. Always want to see 0 before I get rolling here. So go ahead and get your stuff equals 0. I've got x squared plus 4x plus 4 equals 0. And now we're going to go ahead and graph this thing. Is this in standard form or vertex form? This is standard form, right? This doesn't have the quantity squared like number 6. So this is where I got to do a little work, and I got to find my AOS, my axis of symmetry. Quiz or test that's going to be given to you. You just got to be able to know when to use it. B, what's B? The number in front of x is 4, so negative 4. And then 2 times A. What's A? What's the number in front of x squared? 1. Any questions why I'm using negative 4 for B and 1 for A? We do a little simplifying, right? That's negative 4 over 2, which is x equals what? What is that? Negative 2. So we graph that. We count over on the x-axis. 1, 2, negative. And now that's my axis of symmetry. We call that AOS. Now I got to find the vertex. We got to graph this thing. I know the vertex is somewhere on that x equals line. X equals negative 2. How do I find the y value? Plug it in, plug it in. So if I take a look off to the side, the equation I've got is x squared plus 4x plus 4. Anywhere there's an x, I put parentheses. And in the parentheses, I'm going to put in that negative 2. Okay, now, some of you guys just do it right in your calculator. That's fine. Some of you guys do it in your head and your calculator. That's fine. What's negative 2 squared? Negative 2 times negative 2 is 4, right? Is that what you said, Kel? 4 times negative 2 is negative 8. And then plus 4, what was that add up to? What's 4 plus 4 minus 8? 4 plus 4 is 8. And 8 minus 8 is 0. Good job, Kel. Negative 2 zeros right there on the x-axis. Boom. Right there. That's a quiz question. That's one of the ones we did on the quiz. We graphed the rest of this thing, right? Over 1 up 1, over 1 up 1, over 2 up 1, 2, 3, 4, over 2 up 4. Does this thing touch across the x-axis? You betcha. That's the vertex right there. Negative 2. X equals negative 2 is the solution for this. If I plugged in negative 2, we did it right here, we got 0. And that's what we're looking for, is where does this function give me 0? That's also known as a 0 of the function. It's also known as an x-intercept. Okay? All right, let's do at least one more. Let's take a look at number 6. This one set up perfectly. If I take a look, number 6, I've got the opposite of x minus 2 quantity squared minus 1 equals 0. Number one thing I've got is I got 0. So now I'm ready to graph this thing. Yeah. Hurry. This is the good stuff. All right, so this thing's ready to go. And I take a look at my vertex. X minus 1 is moving this left or right. Which way? You see x minus 1, it's opposite of what you see, so it's going to the right. And this minus 1 over here is moving it down. So my vertex normally starts at 0, 0 for y equals x squared, and now it's going to the right 1 and down 1. We okay with that? So I'll write that vertex out for us. Vert for short. I went to the right 1 and down 1. I'm at 1, negative 1. Do we have an a value? Oh, yes, sir. Right there, that's an a value. A is what? That thing's negative. And if it's negative, smiley face or frowny face, it's going down, right? So start at your vertex and follow your normal pattern, over 1, down 1, over 1, down 1. And is this thing touching or crossing the x-axis? Shake your head no, right? Answer. Where does it touch or cross? It doesn't. No solution. So I've given you the 3 different scenarios here now, guys. I've given you one where it intersects in 2 spots. You had 2 answers. I got plus or minus 3. It's not always plus or minus. It just happened to be on this one. Number 4, it actually had the vertex right on the x-axis. That's your solution. And then this one didn't touch or cross at all. That's a no solution. Okay, let's do one more for today, and the rest of the time will be yours. Example 8. Do you have equal to 0? No. So the first thing is always get your stuff equal to 0. So I'm going to go ahead and add this guy over. So now I have the opposite of the quantity of x plus 1 squared. And then I've added this 4 over. So that's plus 4, and now equal to 0. That's a plus 4. So far, so good? All right, let's move this thing. Plus 1. X plus 1. Inside parentheses moves it left or right. Which way? This thing is opposite what you see, going to the left. 4 is going up 4. So my vertex starts at 0, 0. Now I'm going to go to the left 1, and then up 1, 2, 1, 2, 3, and 4. Right there is my vertex. So I've got negative 1, positive 4 is that vertex. So far, so good? Next, I do my A value. Hey, ooh, I got an A. What's A? I got a negative, so that's negative 1. So now I got a frowny face. It's going to follow the normal pattern. Over 1, down 1. Over 1, down 1. Okay, here's my axis symmetry right down the middle here. You want to draw that, you can. Over 2, 1, 2, and down how many? 4. 2 squared is 4, but down because it's negative. 1, 2, 3, 4. Over 1, over 2. Now we go down 1, 2, 3, and 4. That's all I need. I'm trying to find out where does this thing touch or cross the x-axis. And right there, and then over 1, 2, negative 3. So I got an answer here at negative 3, and I got an answer right here. What's this one? That's 1. So if I take my answers, I got negative 3 and 1 as my solutions. So final answer, negative 3 and 1 are my solutions. Yes, ma'am. From the vertex, over 1, down 1. Over 2, down 4. Because 2 squared is 4. Always from the vertex. Yep, always from the vertex. So if I want to go over 3, start at the vertex. Over 3, down 9. Because 3 squared is 9. Over 4 from the vertex, down 16. Because it's negative. Yes, sir. I just keep going until I hit the x-axis. Okay? If I hit it right away, or if I'm on it right away, like this one, we are on it right away, I maybe graph 2 more points, and then I know where the intersection is. Like this one, we graphed 2 points because I knew it's not going towards the x-axis, so I know the answer is going to be a no solution. Okay? Yes, sir.
Example 6. Did you say it was a no solution?
That's on your worksheet. For this one, yes, this is a no solution. On your worksheet, we're going to eliminate that one. You don't have to do number 6 on the worksheet. But this one was a no solution because it doesn't touch or cross the x-axis. Yep. Number 8, the last one we did, yes, that is a solution. In fact, we have 2 of them. Intersects in 2 different spots. Okay. Ladies and gentlemen, that is it for today. That is chapter 9.3, solving quadratics. Okay. Now, what are we doing, Mr. Gotsch? What did we just do? Well, we've done this before, guys. If we look at example 3 back in the day, we also learned how to factor this thing. In chapter 9a, we said, hey, well, we can factor this to two binomials. X and X plus 3 minus 3 are factors of negative 9 add up to 0. We got solutions of b plus or minus 3. Okay, you're essentially adding a new tool to the toolbox on how to solve a quadratic equation. Okay, graphing is the last way. All right, so